Hi, my name is Vana Dumitru, and in this video I'm going to show you how to downsample an IBI series. Thank you for watching. Okay, so before we begin with the actual program that we're going to be using to downsample the IBIs, I just want to show you what the data currently looks like so that you know what we are dealing with. This file right here contains the data for all participants in the study, and if you look down here, you can see I have an individual sheet for every participant in the study. Because this is a dyad study, participants 201 and 202 are part of the same dyad, 203 and 204 are part of the same dyad, and so on and so forth. So you'll notice that participant 201 has a lot of missing data, and the program that we're going to be using is actually going to deal with this missing data, so you don't need to worry about it. I'm going to go to participant 202 just so I can show you what the IBIs look like on somebody who has complete data. So you'll notice up here on the first row I have the question number, which goes from 1 to 18, and each question contains 2 segments, and each is 45 seconds long. So the only distinction between these 2 time points is that during the first time point right here, the participant is working alone, and during the second time point right here, the participant is working with the other dyad member. You probably don't care about this at this point, but you might want to make this distinction a bit later in your analysis. So the actual IBIs that we are interested in start around line 30. So you'll notice at line 28 you have here the name IBI, and then at line 29 you again have the time segments, so you can make that distinction. So each of these IBI columns represent 45 seconds, and the goal for today's webinar is to downsample this data to 5 seconds. So to do this, we will first need to obtain a piece of information for each second of these 45. The reason we have to do this is because the data is not currently structured as a time series, it's simply a series of individual IBIs. So to better illustrate why we cannot use the data in its current format, I'm going to use a text editor and give you an example. Okay, so here I have the data for 2 participants, and let's assume that they are part of the same dyad and that this represents their first time point. So this data represents the first 45 seconds for each of these participants. If you want to analyze this data over time, you would have to pick a time interval, and in our case we picked 5 seconds, but you can choose whatever you think would work best with your data. So in my case, I would need to be able to find where the 5th second occurs for both participants. So to do that, I would need to go ahead and try and add all of these numbers up and see where exactly they start adding up to over 5,000. Because these IBIs are milliseconds, so 5,000 would mean 5 seconds. So the problem is that even if I spent all of this time trying to add these up manually, the chances that these numbers are going to add up to exactly 5 seconds are very small. It's more likely that their sum will go a little bit over 5 seconds, or it might be just right under 5 seconds or something like that. And of course, since participant 2 has different data, it might take a smaller or a larger amount of IBIs to reach the 5th second for this participant. So therefore, what I have to do to obtain one piece of information for each second is try to weigh each of these IBIs within the second that it occurs in. So for example, 437 occurs during the first second, and it is followed by 620. Together they add up to 1,057, so I'm going to go ahead and add this right here. So what this means is we're currently past the first second and 57 milliseconds into the second second. So for IBI 620, part of it occurs during the first second. That's when we reach 1,000 right here. And then another part, more specifically 57 milliseconds, occurred during the next second. So I will need to weigh it within the first second by multiplying it with the fraction of the first second that it occupies. And the same thing applies for all of the other IBIs. Okay, so I hope that makes sense in terms of what I'm trying to achieve here. So now I'm going to go ahead and show you the program that I'll be using. So I wrote the script in Python, and I used Python to run it, but you can feel free to use any other program you prefer. You can find all of these files online on tessawislab.com, and the file that I'm using now is called resampling_task. So I'm going to briefly go through what each of these things mean, but I'm not going to go through the whole process of how I thought about this. If you have any questions, you can feel free to email me. Okay, so up here I have the function definitions. You can see right here. Just as a side note, whatever you see in Python that has a hashtag before it is a comment. So the program will actually ignore that. So I try to add a lot of useful comments for you to be able to walk through the program and understand exactly what it's doing. Okay, so back to function definitions. These right here are functions that just prepare the data for being handled later. So for example, this function right here takes the data from an Excel file, in our case it will be the Excel file that I just showed you before, and puts it into the workspace so that we can work with it. This function right here just ensures that there will be no error when we import this data. Sometimes something like this, a string that looks like this, gets imported from Excel, and you just want to make sure that you get rid of it before moving on. And this function right here turns the data into integers, again, because the data is imported as a string. After you get rid of everything that's not a number, you want to turn that into an actual number that you can make operations on. So the function called downsampling is the most important of all, and this is the one that actually transforms your IBI series into a number for each 5 seconds. So the function takes 3 arguments. The first one is the series, which you will have imported through Excel already, through the Excel function. The second one is this x, which represents the time segment, which in our case will go from 1 to 36, because as I mentioned before, we had 18 time points, each has 2 segments, so in total we're going to have 36 time points. And this function is going to export all of these IBIs into separate files. So for each ID number, you're going to have 36 files. And then the last one is the file name, which is whatever you decide to name your files. So I marked right here that from here on you do not need to change the code. And I also marked below where you can start making changes. So that is actually right here. This is where you can change your code to match your data. One important thing that you should change if you want to do this differently is right here. So here we're averaging for 5 seconds. This is after we have one piece of information for each second. And then we're just going to average that for 5 seconds because that's a time interval that we're interested in. If you're interested in a different time interval, you will have to adjust this. For example, here, if you were looking for 10 seconds, you'd have to change this to 10. You'd have to average 10 IBIs instead of 5 IBIs, and so on. So just make sure that you keep in mind that this is just for averaging for 5 seconds. A couple of important things to change here. So here I'm importing the path. So you'll notice that I have my own directory here. I also wrote a comment, change this to your directory. So just make sure you go and find out where your file is located and change the directory. Also make sure there are no other Excel files in the folder except for your data file, and also make sure that if your file is in an XLSX format, make sure that that is right here. If you have a different version of Excel, just make sure that right here you have the proper extension, because the program is going to look for anything that ends like this. So that's why it's important that it's the only file there. Or if you have your data in multiple files, then that's all right, but just make sure you don't have any files in there that you don't want this program to run on. So apart from this, I also have a list of all of the IDs that I want the program to export files for. If you look here, this is the list called Sheets, and in here I have all of these IDs. The problem is that, for example, right here from ID 206, it jumps right into 209, so it's skipping 207 and 208. Because we have missing data for them, so there is no sheet in the Excel file. So in my case, what I did is I went ahead and gave it a print statement. It's not right here in this program, but I made it print all the numbers from 201 to 326 in this format, and then just copy pasted them in here and took out the 207, 208, and whatever other IDs I knew were missing. If they're just consecutive numbers, then you can definitely use a for loop to do that. So that's pretty much it in terms of what you want to change. There's one more little thing right here. you'll notice that I have this for loop that goes from 1 to 37. It's actually going from 1 to 36 because Python always excludes the last number in this interval. So I wrote right here, actually, that you should change this to the number of time points that you have. So again, I have 36 because we have 18 questions and 2 segments for each one of them. So make sure that you change that as well if you have a different number of time points. Okay, so I'm going to go ahead and run this and see what we get. Okay, so if you remember, the directory that I had in there was IBI series materials, resample, and this is where my files actually got exported. So I'm just going to go ahead and maximize this. So if you look down here, you can see that for participant 201, we have files from 1 to 36. And if you recall, participant 201 actually had a lot of missing data. So for that reason, we have a lot of empty text files. It's still going to export them, and that's a good thing because later when we're going to export this into one single Excel file, it's going to know that zeros are supposed to go there. But if you take a look at one of the files that is not empty, you'll notice that you have right here 9 numbers, 1 number for each 5 seconds of the 45-second intervals. If you remember in the Excel file, I'm actually going to pull this up so that you can see. If you look right here, for example, the last IBI is 14 seconds. So that's very unrealistic for what an IBI typically looks like. That's just because this one is right at the end of the 45-second interval. So because this very small IBIs is included in the last 5 seconds, we're going to have to take the last 5 seconds out. And the same thing applies for the first 5 seconds. So right here, 437, while not that unrealistic, it's still very small, or 106 or 45, and so on and so forth. So in the next step of this program, we're actually going to be left with 7 IBIs because we're going to take out the first and the last one from the 9 that we just saw. Okay, so I'm back to my Python script right now. The file that we're going to be using now is excel_task. And here are a few things that you should change. So here again, I wrote change the directory to your own directory. Same thing applies here for the time points, and same thing right here. So my loop right here is going from 1 to 8. Again, it's actually going from 1 to 7, and that's because after taking out the 2 IBIs, one at the beginning and one at the end, we're going to have 7 IBIs. Here again, change your directory, and then right here at the end, this is how I named my file. It's called final task PGA data, but you can definitely feel free to name it whatever you want. So again, I'm not going to go over everything that this program does. If you change everything that I mentioned before, you should be able to get one single file with all of your data. Again, if you run into any problems, feel free to email me at any point. So I'm going to go ahead and run this program, and we'll see what the final file looks like. Okay, so I'm back to my directory right here, and you can see next to all of the IBI text files, the program exported this one Excel file that's called final task PGA data. So I'm going to go ahead and open this up. Okay, so I have here all of the data. You can see here you have DIDs, and here I have segment 1, segment 1_1, segment 1_2, up until segment 1_7. So again, because we eliminated the first one, segment 1_1 actually means the second 5-second segment, and segment 1_7 represents the 8th segment. And this goes all the way up until segment 36, right here. So basically, this is what the final file looks like. You can definitely feel free to use your data in any way you want right now. You can change its format, but at least now it's in a format that's more easily accessible, and you have one piece of information for every 5 seconds. Okay, that is it for today's webinar. I hope you found this helpful. If you're interested in any other webinars, feel free to check out the resources page on tessawestlab.com. Thanks for watching.